Hi guys, welcome back to YouTube channel Chemistry Live UGPG. Today we are going to talk about chemistry of halogenated hydrocarbon CC6 Unit 1 Lecture 3. So this will be highly beneficial for BSc Chemistry students under CBCS syllabus. So I have a simple message for you guys. Please think for innovation, be creative, learn everywhere, anytime and help to learn others. So today we are going to talk about the nucleophilic substitution versus elimination. So elimination reaction, let's talk about. So E2. E2 means elimination by molecular. So here is the example. So if you start with the alkyl halide Rx and if we give a base B minus, so you will end up with alkene plus X minus and HB. So here is the mechanism. So which occur in a single step mechanism. So here is the alkyl halide. So B minus will attack to this proton and this bond will move here and it will kick out X as X minus. So as a result here you have a transition state like this. So as long as this BH bond starts forming, this CX bond starts breaking. So as a result you end up with alkene plus X minus and HB. So here the rate of reaction depend upon rate constant into concentration of alkyl halide into concentration of base. And the reactivity order of alkyl halides follow this order: Ri greater than Rbr greater than Rcl greater than Rf. So what is the evidence for E2 mechanism? So the reaction following E2 mechanism do not show the rearrangement reaction. The next is isotope effect. Deuterated alkyl halide undergo elimination at a much slower rate than undeuteраted one. So here you can see this is undeuteраted one. So in presence of ethoxide ion, so you can get alkene. So the relative rate is 7. And if you take the deuterated one in presence of ethoxide ion, so you get this alkene. So the rate of reaction is only 1. So very slow. So next is U1 mechanism. So elimination unimolecular. So example, you take alkyl halide in presence of base, you would get alkene plus the BH plus X minus. So this E1 mechanism has two steps. So first is this alkyl halide will undergo ionization, giving rise to carbocation plus X minus. So in the next step, which is this step is slow. In the next step, the base B minus will take this proton and this bond will move here. So as a result you get alkene and HB. So this step is fast. So the rate of reaction is K into concentration of alkyl halide. So the order of reactivity of halides follow this order: allyl, benzyl greater than tertiary, greater than secondary, greater than primary, greater than methyl halides. So let's talk about the substitution versus elimination, SN1 versus E1. So generally what happens in SN1 mechanism, so the alkyl halide would break, giving rise to the ionizing species R plus plus X minus, so the carbocation. So the carbocation tend to eliminate suitable proton in presence of a base to form the more stable alkene. So here you can see the example. So this Br goes as Br minus, so you generate this carbocation. So here again the hydride transfer takes place, giving rise to more stable carbocation, tertiary carbocation. So when it would give E1 mechanism, so this ethoxide take this proton and this bond will move here. So as a result you get a more stable alkene. So here is the orientation in elimination reaction. So here you can see, so suppose we take this alkyl halide. So here this is CHX. So this side the proton can be lost and this side also this proton can be lost. So let's mark it as A and this proton is B. So which proton will be lost? So let's talk about. So in presence of a strong base CH3ONA, sodium methoxide. So what would happen? So when it would undergo Hofmann elimination, you get less stable alkene, so less substituted alkene. So when it would give the more substituted alkene, So that will be the Soyuz product. So in E2 mechanism, so X becomes I, Br, Cl, so you get 2-pentene, that is Soyuz product as a measure. And when X equal to F, so you get 1-pentene. So that is Hofmann product as a measure. So when this I, X equal to I, Br, Cl, the good leaving group, so the transition state have more alkene character. So hence the Soyuz product, more stable alkene. When this X equal to F, the poor leaving group, so the transition state have more carbanion character. So this primary carbanion is more stable than the secondary carbanion. So hence Hofmann product is the major product. So here you can see, so if this CF bond will cleave, so this would give rise to secondary carbanion. So that is less stable. So if this one cleaves, so it cleaves slowly, and this one cleaves fast. So as a result, it would give rise to primary carbanion. So it will be more stable. So next is E1 orientation. So E1 reaction lead to carbocation, and elimination is predominantly Soyuz. So here you can see. So we have this alkyl halide. So from going from primary to tertiary, so E1 and SN1 reaction mechanism will increase. And from going tertiary to primary halide, so E2 and SN2 reaction will increase. So E1 and SN1 reaction increases from primary to tertiary alkyl halide as the stability of carbocation increases from primary to tertiary carbocation. Similarly, E2 reactions are favored by strongly basic reagents such as amide ion or alkoxide ion, tertiary butoxide. But weakly basic reagents like acetate or I- will favor SN2 reaction. Similarly, high temperature favors E1 over SN2 reaction. And in SN1 mechanism, the solvents of high polarity and reagents of low nucleophilicity. So this SN1 reaction will favor. This E1 for E1 reaction mechanism, the solvent of low polarity and reagents of high nucleophilicity is required. So please subscribe to our channel Chemistry Live UGPG. So this is also available in the website www.chemistryliveuGPG.com. For class 11th and 12th students, this is the channel Foundation Chemistry AV. So this is a simple step towards e-learning, making life better. Thank you all for learning.